This week I completely ported a code from my custom engine to Unity. That includes all graphics, all movement, sound, entities, interactions, effects, and all the small but important details. Now we will go over each day of development and see what I've done. First thing first, I fixed the game resolution to 320 to 180 to get a nice fixed grid of pixels, and placed the player and started working on the tile maps. But before that, I want to define what a pixel and a tile is in the context of the game. You might think these are very basic concepts, and you would be right. But every single object in the game depends on the pixel and tile coordinates. So any gaps in their definitions have a compounding chance to cause problems down the line. Thus, I'll define a pixel and a tile so clearly here that I can take them for granted for the rest of development. Okay, in a chord, a pixel is a 1 by 1 square area, pivoted to its bottom left corner. 1 by 1 might seem too big, because I suppose Unity gives a default value of 100 to the pixel size. So that means 10,000 pixels fills 1 unit area. But it doesn't matter at all because scale is relative. If you scale everything by 100, you didn't change anything about the scene. You just change your coordinates. And the coordinate space where the pixels are 1 unit large is almost objectively better. Think of it this way. If I'm moving 6 units per second, I can now visually intuit that I will move 60 pixels in that second. And why do I pivot them to the bottom left corner? Why not the center, for example? Well, again, because it makes the math easier. Suppose you want to calculate what pixel the point 3.4, 2.3 lies in. You can just floor both numbers to get 3, 2, and that's the pixel coordinate, which is the bottom left corner of the pixel in the real coordinate space. And as you know, flooring is basically not reading the decimal part of the number. So the mental overhead of this approach is actually negative. As you can see, 0, 0 is off center, kinda leaning to the positive part. It's unsymmetrical, but it turns out to be better this way. Next up, tiles. Tiles are chunks of 8 by 8 pixels, with the exact same rule as pixels. And the bottom left corner of the tile 0, 0 coincides with the bottom left corner of pixel 0, 0. So if you put those facts together, now you can see that calculating the tile position is also very easy. You divide by 8 and then floor. And that's it for pixels and tiles. Now I will use tiles to make rooms, and later I will use rooms to make the world. Okay, let's continue where we left off. I started by making the tile map system, and I also did auto tiling so that the tiles automatically get their sprites updated based on their neighbors. And normally when you're creating tile maps, the graphics for the tiles, you come across a lot of edge cases and you have to create a lot of different tile sprites. Instead, I'm using something called dual gridding, which simplifies the process a lot, and you only need to create, I think, 15 tiles in total to represent the entire tile map. I would like to go into more detail on dual gridding sometime later. Then I added tile collisions and a simple player controller that can move left and right and has gravity. Then I added the ability to jump. Then I added some jump squish to make the movement more dynamic. And here I've added some animations for idling, walking, jumping, and falling. And to close the day off, I added a basic dash ability. First, I started by adding a moving platform. It's actually way more complicated than just colliding with tiles since you have to move the player with the platform. Then I added a tile editor to the scene view so that I can edit the tiles without having to enter the game each time. Later, I added one more room and the player can transition between rooms now. Then I disabled the rooms the player is not in. And I think you can see that right when the player is between both rooms, there's some kind of flickering going on. And that's because the player checks if the room fully contains the player, and if it's not containing the player, then it switches to the other room that overlaps with the player. And when that happens every frame, it switches from A to B to A to B to A indefinitely. So I push the player just enough so that he is outside the current room and just inside the next room. And finally for today, I added a few frames of animation when the player is switching between rooms, and the game is paused during this time. So I added some particles to make that clear. Starting today, I added the rest of the movement states to the game, like wall jumping and rolling. And then I added some basic camera movement and some bigger rooms. Then I added camera smoothing when the player is switching between rooms. And finally for day 3, I added the rest of the jumping parameters. So for example, if you jump while you are standing still, it just gives you a vertical boost. If you jump while you are dashing, it gives you a horizontal boost as well. And if you jump while you are rolling, it gives you a small amount of vertical speed but a big amount of horizontal boost. Now that the mechanics are mostly in place, I went into visuals and added a slight bloom effect, and I also added an outline to the player. Then, because I want the player to flash brightly when important things happen, I made a basic overlay color shader. Right now, this effect is used when the player regains their dash. And then I added depth, so when the player falls off the screen, they just respawn at the checkpoint. Then I added spikes so that the player can die more easily. After spikes, I added the igniter, which ignites the player when they stand on it for too long. Then I added the essence, which refreshes the player's dash when collected. Then I added the attractor, which attracts the player to itself if they get too close, and then pops. The player can alternatively dash to pop the attractor right away. And then I added the turbine, which adds some speed to the player. For example, this is an up-facing turbine, so it gives the player a vertical speed boost when they jump. And here are all the entities I've added together. One thing that irritated me was the sound effects. They seemed kind of off. I think it's because when the sound is spawned, I don't move it with the player, and because player is the one listening to sound, it has some kind of Doppler effect that messes the sound up. So I fixed that by making the sounds have no fall off. First thing, I made the entities reset when you enter their room. So right now, if you focus on the moving platform, you'll see that it always begins at the exact same position when the player enters the room. I added a dash trail. I think it's a very cool effect. I added tile variations, added background tiles. Background tiles are actually very useful in directing the player and creating contrast between the foreground and background elements. Then I added a bunch of particle effects to all the entities. And then I added some footstep and rolling sounds. And that's pretty much all I've done this week. Now let's see the game in its current state and the previous week when the game was still inside the custom engine. I think the porting process went really well. I ported everything I wanted and still had some time to add some new stuff like all that particles and the new sound effects. And now I'm realizing that the bloom effect was a little too strong on the previous version. I think it looks way better now. Next week, I will be refining the movement further, adding a user interface, and improving the graphics.